Hi there. For this video, we'll be answering some examples on how to simplify radicals. Basically, we'll try to apply the laws of radicals as well as some laws of exponents out here. So let's have this example. Let's have the square root of 441 a raised to 6. Now, as a hint on how to start with this, since this one has no index, so we know that its index is actually 2. So our goal here is to convert the expression, this radicand out here, into perfect squares. So first, let's observe 441. Note that 441, we know that this is divisible by 9, since by the divisibility rule of 9, if we add its digits, the outcome is 9. So we can split this up into 9, and 9 divided by 441. This will give us 4, 36, 8, 1, and 9. So, we have here 49. And now note that 9 is actually equal to 3 squared. And 49 is equal to 7 squared. So we can write this one as the square root of 3 squared times 7 squared. This is for 441. For a raised to 6, note that we can write this one as a raised to 2 times 3. Since 6 is 2 times 3, then by laws of exponents, we can write this one as a cubed squared. So we'll have here a cubed squared. Let's remove this one. Now from here, we will apply the second law of radical. So we can write this one as the square root of 3 squared times the square root of 7 squared times the square root of a cubed squared. Now by the first law of radical, since we know that this one has an index of 2, we can cancel this one out. So we'll just be left with 3 times 7 times a cubed, or simply 21 a cubed. And that is the answer. Let's go on to our second example. Let's have the cube root of 135x y raised to 4 z raised to 9. Since the index out here is 3, our goal is to factor the radicand in terms of cubes. So first, focusing on 135. Note that clearly 135 is divisible by 5, since by the divisibility rule of 5, it ends in 5. So we'll have here 135, 5, and 5 divided by 135. We'll have here 2, 10, subtract that, 3, 5, and then 7. So we have 27 out here. Then note that 27 is equal to 3 cubed. So we can write this one as 5 times 3 cubed. Then for x, since we can't really factor that one out, we just copy x. For y, note that y raised to 4 can be written as y raised to 3 times y raised to 1 by loss of exponents. So we have here y cubed times y. Lastly, for z raised to 9, by loss of exponents as well, we can write this one as z cubed times 3 or z cubed raised to 3. So we have here times z cubed raised to 3. Now we apply again the second law of radical. So we'll have here, what we do is we extract the factors that are perfect cubes. In this case, the 3 cubed, the y cubed, and the z cubed raised to 3. So we have here 3 cubed times y cubed times z cubed raised to 3. Let's move this one. Times, the expression left is 5xy. This one. And from here, we can apply again the first law, wherein, since we know that, oops, I forgot the index, should be a 3 out here. Since the index and the exponent is the same, we can cancel that one out. So we'll have here this. So the answer will become 3 times y times z cubed times square root of 5xy, or simply 3y z cubed cube root of 5xy. Note that we can't simplify this one anymore since the exponents inside are 1. So there are no perfect cubes anymore inside this radical. Let's have this third example. Let's have the square root of 343 m raised to 5 n raised to 8. Again, since we have an index here of 2, we try to factor out these expressions inside into perfect squares. So first, for 343, although it doesn't seem like it, but this one is actually divisible by 7. So we have here 7 divided by 343. This will give us 4. 28. Subtract that will give us 6. Then we have here 3. This will be 9. And so we have here 7 and 49. Then note that 49 is equal to 7 squared. So 343 is actually equal to 7 cubed, or 7 squared times 7. So we'll write this one as 7 squared times 7. Since again, we want to factor the radicand or the expression inside in terms of perfect squares. Then for m raised to 5, note that we can write this one as m raised to 4 times m raised to 1, or simply m raised to 2 times 2 times m raised to 1. We can remove the 1 out here. Or m2 squared times m. So we'll have here m squared times m. Lastly, for n raised to 8, we can write this one as n raised to 4 squared. So we'll have here n raised to 4 squared. And again, by applying the second law, we can extract this perfect square out here, this perfect square out here, and this perfect square out here. So we'll have here the square root of 7 squared times the square root of m squared times the square root of n raised to 4 squared. And the one left is 7 and m times 7m. From here, we apply again the first law, so we can cancel this one out here. And so we'll be left with 7 times m squared times n raised to 4 square root of 7m, or simply 7m squared n raised to 4 square root of 7m. And this one out here is the answer. Let's have this one final example. Let's have quantity the square root of the cube root of x squared y cubed squared, and this whole is cubed. So this might seem tricky at first, but what we do is we first apply the fourth law of radical inside here. So this one can be written as quantity, we have here 2 out here, so 2 times 6 is, 2 times 3 is 6. So the 6th root of x squared y cubed square raised to 3. Now we can apply the laws of exponents out here, but I'll try to incorporate the laws of radicals instead. Since first we have a cube here, we can write this one as the 6th root of x squared y cubed squared times, we multiply this 3 times to itself. So let's resize it so that it will fit right there. And by the second law, we know that since the nth root of xy is equal to the nth root of x times the nth root of y, we can do the opposite. So this one out here, from this one, we'll go to this one. So we'll have here the 6th root of x squared y cubed squared times x squared y cubed squared times x squared y cubed squared. Or this one is simply by laws of exponents this time. This is equal to x squared y cubed raised to 2 plus 2 plus 2, or 6. And now it might seem clearer already since we have the same index and the same exponent out here. So by the first law of radical, we can cancel that one out. And this one will simply be equal to x squared y cubed. And that is the final answer. So that is how we simplify radicals. So basically, we try to apply the laws of radicals that we previously discussed in the last video. To end this, here are two exercises that you can work on. So first, we have the square root of x squared plus 6x plus 9. And the second one here, we have the cube root of negative 512a raised to 8. So these are two helpful exercises that you can try to improve your skills in applying the laws of radicals and simplifying radicals in general. So feel free to comment down below your answers and solutions to these exercises. And that's it. And that's all for this video.